ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः।
So, is there any questions on what we did in the portions which we covered in the last class? No? Okay. I hope now all of you know how to deal with isoparametric elements, but we have to continue a bit because we have not completed isoparametric elements. Quite a bit of things have to be done before we close this chapter. Maybe next 2 to 3 classes we have to do it. This is a very important, as I have been telling you, that this is a very important element. Isoparametric element is an important element because this is a concept. Isoparametric element is a concept. It can be used for a variety of elements. Okay. In fact, after this, maybe next 2 classes, I will derive the an element for heat transfer, okay, which I gave as a problem in the test, and that this will also be derived. So, in other words, we will look at those problems as we go along. Okay, it will be solved as we go along, but what I want to emphasize is the fact that it is very important that we understand isoparametric elements. Okay. Now, we will look at when we even interpret the results, then also we would be interested in the theory of isoparametric elements. In other words, from further on, from now on, the course is going to go something like this. I am going to teach isoparametric element and finish them, okay, next 3 classes. Then I will deal with beam elements. Okay. I am not going to go into the details of plates and shells because it requires lot more theory and we do not have the time to cover in a first course. Nevertheless, I am just going to indicate the type of shell element and axisymmetric shell, what it means, what are the types of say degrees of freedom and so on. Now, I am just going to just talk about that in for a short time. I will not be in a position to derive them because that requires a lot of background and also time. So, once we complete that, then we will take a break to look at how to interpret results. I am not going to cover in this course solution techniques. Finite element is a very vast field. Okay. In other words, KD is equal to R or F, that is only one part of it. Then I have to solve them, I have to apply boundary conditions and solve them. See, all of you have been solving this kind of problems, small things which I had given you, by using Gauss elimination. Okay. That is the technique many people still use it, but there are lot more advanced techniques which make things faster. Okay. What are called as precondition conjugate gradient methods, relaxation techniques and so on. So many things are there, but we are not going to cover all these things in this course. Again, that requires a big background in linear algebra and so on. So, we are not going to cover that, but nevertheless, if you know Gauss elimination, which you would have studied in 8th standard, that is enough to understand that you have to solve this problem and enough to go further, because if at all you are going to use a package, you are not going to solve this, but if at all you want to write a package, then with this knowledge you can always pick up as to how to solve problem. They are all readily available today. Okay. So, it is a specialized area, again I am not going to cover that, but what I am going to do after certain looking at niceties of results and niceties of interpretation and so on, we are going to go to an introduction to nonlinear finite element analysis. How exactly nonlinear finite element analysis is done, That is what I am going to talk, in other words algorithms that are used. We are going to talk specifically about what are called as increments, iteration and so on. In that respect, I am going to bring in the formulations that are used for solving manufacturing problems. In fact, there are a number of formulations that are used. It is again not possible to cover all these formulations. We need 3 courses like this if you want to cover all those things. It requires lot more basis on basic understanding of what we call as continuum mechanics. Hence, again we are going to look at one of the formulations which is very important, which is extensively used, for example, to solve problems in say metal forming, okay, what we will call as fluid formulations or flow formulation rather. So, this flow formulation is what I am going to emphasize, okay, as the next step. So, after beam element some results and then flow formulations. Okay. So, if you have time further we will talk about contact formulations as well. Okay. See, many of the principles that are used in metal forming simulations I will indicate it and we will look at it with some practical examples. Again, okay, applications of finite element to say metal forming is a huge area. So, we are not going to talk about again sheet metal because that requires knowledge of shells and so on. Okay. So, but we are going to talk about application of finite element to bulk forming processes, and where many of the techniques that we have used will be of use. Okay. So, why I am saying this is because this topic is extremely important. Once you understand this, the application of this topic to many other fields or many other fields of application of finite element becomes rather routine. So, tomorrow you want to go and do the heat transfer problem, want to determine temperatures. The issues are very similar to what we have done now. Hence, you please follow whatever I am saying. Okay, we stopped this problem at this place. We said that one of the major say I would say issues here is to write down the stiffness matrix of a triangular element. We also gave a reason why triangular elements are important till recently, and tetrahedron elements, its big brother, its 3-dimensional brother, is very important even today. Basically because most of the softwares generate triangular element, and now yes, there has been some change, the technology has moved, then now they are capable of generating 4-sided quadrilateral elements. But even today most of 99% of the softwares, okay, unless you make efforts, lot of efforts, okay, when you say automatic meshing, that means you do not make efforts, the software does only tetrahedron elements. Unless you make an effort, okay, by what are called as mapped meshing, which owes its origin to Professor Zinkiewicz in the early 70s, okay, then only do you get an element which we call as a hexahedron element, which has 6 sides, or else you still have the big brother of triangular elements, that is the tetrahedron elements. Or in other words, what I mean to say is whatever we are talking about for triangular elements can be, many of the properties can be extended to this kind of tetrahedron elements. So, once you understand the basis of these elements, then it is very easy to extend them. Now, there are 2 ways in which we can develop the stiffness matrix of a triangular element. There are 2 ways. One is to collapse a node, which is probably the easiest, okay, to understand, and many softwares do it, okay, in this way, as well as in another way which I am going to discuss later. One way is to collapse. For example, look at this element. Okay, this I have given specific dimensions in order that we can work out a problem and you get a feel of what is happening. Okay, I do not want to be vague, and hence I have given some dimensions to it. So, for example, if I collapse this 1 onto 2 and get an element. Collapse means make this coincide or make x1 is equal to y1 and x2 x1 is equal to x2 and y1 is equal to y2. When you make like that, then the resulting element becomes a triangular element. Is that clear? Now, what I am going to do is to proceed in this fashion, okay, and work out a B matrix to it. I want to show some peculiarity with the B matrix. Okay, what happens to the B matrix? Now, the procedure can be written as a code and so on, okay, or you can follow a second technique for the generation of stiffness matrix of a triangular element, which people call as area method. Okay, we will keep that, we will just reserve this area method for the next step, and let us now look at this, because you get some nice results with this. So, your understanding will also go up looking at this. I need your help in working out. I am sure all of you are familiar with this problem, because last time also I left it at that stage. So, let us see how to work out this problem. So, these are isoparametric elements, and hence I can write down, say, x by means of our well known formula ni xi. Now, by the way, what is n1 in this case? I think there has been mistake in this as well. Okay. Yes, look at the way I have numbered it. I have deliberately done it. Look at the way I have numbered these things. See, where is 1, where is 2, and so on. Okay. So, it is important that you understand that you can't blindly put n1, n2, n3 and n4, and hence I say n1 is equal to 1 by 4 into 1 plus psi into 1 plus eta. Is that clear? So, what is n2 now? 1 by 4 into 1 minus psi into 1 plus eta. N2's position is 2 here, okay, and 3 n3 is equal to 1 by 4 into 1 minus psi into 1 minus eta, and n4 is equal to 1 by 4 into 1 plus psi into 1 minus eta. Okay, it is very simple to just check this up, substitute them in these equations, in these triangular coordinates. You will see that our familiar properties are satisfied. Is that clear? Okay. So, my first step is to substitute this here, and as well as y is equal to ni yi. So, please note, what am I doing by writing it like this? I am invoking my isoparametric principle, the basic principles of natural coordinate system. Is that clear? So, my first step is to substitute these equations into this equation, and then substitute or put x2 is equal to x1 as well. So, that now I can write down. So, what do I do ultimately? I am reducing the coordinates, so that I can write down, for example, x in terms of x2, x3 and x4, right. So, let us see how I write it. So, x is equal to, so 1 by, so this becomes, I will just write it here, so that you can just follow this easily. So, now x1 and x2 becomes the same. So, what happens to x? 1 by 4 into what? 1 plus eta into, no, first let us write it down in terms of x2, x3 and so on, okay, into 2 x2, right. So that and this goes off, and so I get 2 into x2, okay, plus n3 x3 plus n4 x4. Right. Okay. Similarly, I can write down y as well Is that clear? Fine. So, my next step is let me substitute the coordinates x2, x3 and x4 from this figure. Okay, let me substitute it from this figure onto my equations, right, so that I can write down now x and y. So, x is equal to, can someone help me take a minute to look at that and then substitute this. What happens to x2? x2 is 0, x3 is 0. What happens to x4? 2. So, x4 is here 2. So, 1 plus I into 1 minus eta by 2. Is that clear? How many of you did this problem? How many of you did this problem? Not even one. Not by, how many came up to this step? Very good. Let us see. Okay, just think with me. Let's see whether you are able to do it. But none completed it. But then you will be surprised when I do it that this is one of the simplest problems, because I am just going to follow exactly what I did for the previous case, nothing more than that, right. Okay. Now, what is y? Substitute now for y2 and y3 and so on. Yeah.
Now x1 is equal to x2 now, sir.
Yeah.
Then the first equation, instead of that, when you put half of 1 plus eta and x1, you get an additional term there.
1 plus eta into
When you write x in terms of x1, x3 and x4.
no, when you whether you write it in terms of x1 and x2, okay, you can write, you are saying that I will write it in terms of x1, x3 and x4.
That term x1
Okay.
is not 0.
No, x1 is equal to x2, x1 is equal to 0. No, I don't follow your question. You can if you want, you can eliminate x2 and write it in terms of x1, x3, x4. Right, x1 is equal to x2, so what does it matter? Is that clear? Okay. So, y is, what is y? 1 plus eta. Okay. Now, why I did this is because I can keep it as it is. I can keep it in terms of x1, x2, x3 and continue, but then my algebra becomes very big. I am solving a particular problem. That is why I substituted it, or else I need not substitute it. I can keep it as it is, so that I will get a much more general picture. But then since we are only illustrating one problem, okay, I have just substituted it, right. Is that clear? I need not have substituted. If that is your doubt, I need not have substituted it, but then I will again fill up the board with lot of numbers, then it becomes very confusing and you may miss the central result of this problem, and that is the reason why I wrote that. Is that clear? So, what is my next step? What am I trying to do? I am trying to solve this isoparametric problem. So, I mean, I want you to listen because none of you have done this problem. So, it is very important that you understand it. What is that I am trying to do? What do you think is the next ultimate step, not the immediate step? What do you think is the next ultimate step? Jacobian, right? Right. So, why not I calculate the Jacobian? Is that clear? Any questions? Okay. Now, calculate the Jacobian. I will give you 2 minutes, just do that. Just look at these things, look at this, and then calculate and write down Jacobian. What is it? Dou x by dou psi, dou y by dou psi, dou x by dou eta, dou y by dou eta. So, substitute them and check what you get. Who's going to give me the answer? One minus eta, 0 minus of 1 plus psi 2. Beautiful. Simple, dou x by dou psi and so on. Okay, that is the one part of the story. Now, you have not yet answered, this is the second step, Jacobian, but you have not yet answered what is it that I am interested in. What is the problem that we are going to look at B matrix. We are going to look at B matrix and see how B matrix is going to look like. So, my whole idea is to go to B matrix. Is that clear? So, what is it that I should do in order that I go to B matrix? Dn, okay, J inverse, yes, of course, I have to calculate J inverse, right. So, what is J inverse? Let us do that straight away because J is available here. What is J inverse? Just calculate that and let me know. Yes? No? 2 upon 1 minus eta 0, right? 1 plus psi 1 minus eta, beautiful, 1, lovely. So, see, the only way to learn this subject quite thoroughly is to do these things, okay, so that you will get familiar with each step. Fine. So, now we have J inverse. Right. Now, what is my next step? What is the other principle that I am going to invoke? What is the other principle that I am going to invoke? Okay, let me remove this. I think you know all this N's and you have it in your notebooks. So, what is the other one? I am going to now write, obviously, what is it I am going to write? U in terms of Ni Ui and V Ni Vi, right. So, sigma is implied because Ui I am just repeating, and sorry, U V is equal to Ni Vi. So, what am I going to do here when I collapse? When I collapse, what is that I have done? u1 is equal to u2, that is all. u1 is equal to u2. Now my degrees of freedom becomes u2, u3, u4, v2, v3, v4, period. Okay. So get that, so that you can now write it in terms of, say, n1 or u1. Okay, I will not write that 1 plus, I mean same thing what we wrote in the previous case, half into 1 plus eta into u2 plus n3 u3 plus n4 u4, right, and that is equal to half into 1 plus eta into v2 plus n3 v3 plus n4 v4. So we have invoked two principles which we used for isoparametric elements. What is my next step? What is that I should calculate? dn. Okay. In other words, I should calculate dou u by dou psi. Why? Because ultimately what is that I want? Dou u by dou x. Very good. So I want dou u by dou x, dou u by dou y, and so on, okay, because in order to calculate b, I need them. Remember, I had that ones and zeros matrix multiplied by our u comma x and so on, okay. So my next step is to calculate dou u by dou psi. So what is that equation? If you remember, just get that in your mind, that is dou x by, say, dou u by dou x, and say dou u by dou y, and so on. What is it that, so what does it involve? It involves J inverse, okay. So we will go to that step as a next step, but before that, what is that I should calculate? dn, okay, or dn consists of, I have to get dou u by dou psi. Right, that is what is my next step. I have to calculate dou u by dou psi, dou v by dou psi, dou u by dou eta, and dou v by dou eta. Okay. In other words, you can split this up into dn into, what is it that you will get? dn into d, right. So your, what is d in this case? So you can write down, say, in other words, just to preempt what we are going to do, in other words, b is equal to those zeros and 1 matrix, okay, which you have it, refer to your book, multiplied by what? What did we write it as? Yeah, right, gamma s we wrote, remember, 0 gamma s into D matrix, small d. Small d, what are they? They are the degrees of freedom. Sorry, okay. Sorry, dn into d. Let me remove this b. That is actually, no, sorry. Yeah, and so this whole thing becomes b. Is that clear? How many of you had come to this step? I mean, there is nothing that we have done. It's very same procedure, whatever we have done. Has anyone come to this step in the exam? What exactly was the problem? You know, let me You just go back and try why you have not done this. Is there any difficulty in understanding this? What is the confusion? So whatever step I have written is known to you, right? In fact, B matrix I have told you so many times that this is B matrix, right? The only difference now is this D is now a compressed D. So 1, 2, 3, 4 we have only 2, 3, 4. That's it. Right? Okay. Now I'll give you 2 minutes. I want you to calculate, say, Dn. Just calculate Dn and tell me what is Dn. Just do that. So even since you have not done it before, I would like you to do that and tell me what is Dn. Any questions? Because you have not done it, is there any confusion? Is there any anyone has not understood the steps? Yes? Okay, now it is clear, everything is clear. It always happens that after the exam everything is clear, and in the exam you don't work out usually, and that's a problem with all of us. Even when I was a student it was the same problem. So let us see now. Let's see how many of you get this problem correctly. Let us just stick to only 2 terms so that we will not get all the things, right? I mean, because it's a very big matrix. So we'll just stick to only So in other words, okay, let me make this problem simpler. Just calculate dou u by dou x and dou u by dou y. Okay, we will not do all the things. Okay, we will just stick to the first one, dou u by dou x, like only one variable, dou u by dou x and dou u by dou y. Similarly, you have to do dou v by dou x and dou v by dou y. Okay, so just dou u by dou x and dou v by dou y. So they will have, it will be J inverse straight away, okay, J inverse, and then we'll have another that dn term, okay, followed by small d's, I mean followed by u1 and so on, u2 and so on. Just these terms. Yeah. Correct. Correct. That's what I want you to work out. That's what I want you to work out. Correct. Correct. Substitute. That's what I'm asking you. What is it? What is this value? You can directly get it. Okay. See, you have, what is that you have here? Dou u by, see, can you fill this equation? Dou u by dou psi, and here dou u by dou eta. Right? Okay. So what I am trying to ask you is, so this, what is this? What is this? This can be written as Ni ui. Okay. Same way here also Ni ui. Is that clear? Okay. So how do I write this? How do I write this thing? So dou Ni by dou psi, dou n1 by dou psi, dou n2 by dou psi, or dou n, there are 3 terms, u1, u or u1 is equal to u2, so u1, u3, u4, right? Clear? So you will have some term u1, u3, u4, just for illustration. Okay. Then you can write the same thing for dou v by dou x, dou v by dou y. Combine them together. That's all. Appropriately place it. So what will be the first term here? Yes. What will be the first term? No. What will be the first term? Dou n1 by dou psi. Okay. You remember that whatever we had written, it's not actually n1, but a combination half of 1 plus eta, right? That will be the first one, because that is that multiplied by u1. Is that clear? Okay, because n1 and n2 we have combined them together. What is that? How did I write? U is equal to half into 1 plus eta into u1 plus n2 into u2 plus n3 into u3. That's how I wrote. So the first term here would be that dou of dou psi, okay, into half of 1 plus eta. Is that clear? What? Yes or no? Okay. So first term is 0. What would happen to my second term? Why is that it's 0? No, look at the way I have written it. To just make it simple, I have just written only in terms of u's. Okay. If you want, you can write it also in terms of u as well as v, just to make things simple right now. Okay, I have written it in a simple fashion. So minus 1 by 4 into 1 minus eta. Minus 1 by 4 into 1 minus eta. Plus 1 by 4 into 1 minus eta. Right. Is that clear? So what would be the other things? Here it is dou u by, or that 1 half of 1 plus eta, that has to be differentiated with respect to eta. So what will be the first term here? Half. Very good. See, so simple, nothing there. So then you have to differentiate the second term. Second term, when you differentiate it, minus 1 by 4 into 1 minus psi. Very good. So what will be the third term there? Is it minus 1 by 4 or plus 1 by 4? 1 minus, sorry, 1 plus eta. Very good. So now I want also dou v by dou x, dou v by dou y. Okay, I can write the same thing in a similar fashion. Sorry, okay, same I say, whether u1 or whether u1 is equal to u2, okay, so u2, u3, u4, right? Is that clear? Okay. Now what is my question? My question is, how is this B going to appear? That is my whole question. How does the B matrix appear? Okay. Now I can look at it even here to tell how B is going to appear. What is that I am going to do? Substitute for J inverse, I already have it, multiply it with this equation or with this matrix, and tell me what is that you will get, because that will get repeated. I have to only readjust it, nothing great in it. Or in other words, what I want you to do is to substitute for J inverse, multiply here multiply it and tell me how dou u by dou x and dou u by dou y will appear to me. Okay, I will just write it here itself, dou u by dou x and dou u by dou y, how it will appear to me. You had J inverse, right? What is J inverse? Yeah, 2 by 1 minus eta 0, 1 plus I into 1 minus eta 1, period, that is it. So, substitute it there and multiply it, simple multiplication, that is the reason why I just stopped with that, and just tell me how it will appear. So, now you know how to calculate dn. Our regular dn is what? Just expand this to u2, v2, u3, v3, u4, v4, okay. Similarly put 0 here, keep on expanding that, right. Is that clear? Very simple, no problems. So, that is done. So, now multiply J inverse and this and tell me what is that you get out of it, and the result is very important. If you want for your what is J inverse is 2 by 1 minus eta 0, 1 plus I into 1 minus eta and 1, right, am I right? Yeah, just for your reference. And so, just substitute that here, multiply it and tell me what is that you are going to get. Okay, first one is half. Wait. Slowly tell me, let everyone complete it. So, first term is 0 minus half, next one half minus half 0. So, what does this tell you? So, my B matrix can be, once I know this structure, I know how B matrix is going to look like, right. Is it clear or not? Is there any confusion on this? I have taken a part of B matrix and worked out, because I do not want to write again fill the board, that is why. In other words, I can write down dou V by dou x, dou V by dou y, it will have the same form, but will be multiplied by what? V2, V3, V4, period. I can now combine them together to write my big B matrix. So, what does this tell you? It is constant throughout the triangle, okay. B is a constant the whole of the triangle. You go back and look at what we did with the other element, our quads. Quads were not like this. So, what does this give you from using a triangular element? Suppose there is a place where strain changes, okay, then obviously the strain inside a triangular element is going to be a constant. Strain inside a triangular element is going to be a constant, and hence I will be hard put to save myself if I use a triangular element in that area, a big triangular element. But there is one big but. If I use many number of elements, okay, then the problem is obviously to great extent alleviated, because I can fit any curve by means of, when I take more and more elements, by means of small steps. There are other peculiarities to this element. I am not going to answer that now. I want you to keep this in mind, that the constant strain state, I will answer it in the next class, okay, when we look at what is it that we are going to get out of finite elements. So, the lesson number 1, major lesson, if you want to use triangular element, or as I told you, as I called it as a big brother, the tetrahedron element, then you have to be careful in meshing, because especially when there is a strain change, for example in bending strain changes linearly, then if you use this kind of elements you will be in trouble, and that is what I showed you in one of the exercises which we did, okay, in one of the classes. Is that clear? Okay. Now this exercise was not very difficult, I am sure now you all agree that it is not very difficult, quite straightforward, but it can't be that easily extended to higher order element, or in other words you may look at it and say that it is a simple thing, but can I have a much more general technique of doing a triangular element in the same fashion as you did our quadrilateral element? Is it, that is our question, is it possible to have an element? Why is it that I am looking for a much more general issue? I will come to that in a minute. Okay, is it clear? You can go to the next issue. Fine. Now what we are looking at so far are what are called as only a linear element. Next class I will illustrate that we can move over to a more quadratic elements. For example, I can say that a triangle element, okay, can have more than 3 nodes, okay, like I have say a quadrilateral elements can have more than 4 nodes. Say for example in a triangular element, apart from these 3 chaps, I can put nodes at other places. Why am I doing this? Because I am stung by the criticism that B is a constant. Why did B become constant? Because of a simple fact which I illustrated about 4 or 5 classes back, that U is written in terms of x and y, a0 plus a1x plus a2y, but all those things are camouflaged in whatever I did, that is why I did that much more elaborately. But if I can use not a linear interpolation but a quadratic interpolation, okay, I can to great extent solve this criticism. In fact, today for many of the very large deformation cases there have been elements which have been developed which are triangular elements, okay, with 6 nodes and perform extremely well under much more difficult conditions. The major advantages with good mesh generators, okay, triangular meshes are very easy to generate and I can use those generators. So I have a need to develop a much more general technique, okay, for a triangular element which can accommodate not only just a linear triangle or constant strain triangle as it is called, but higher order triangular elements like this which has say 6 nodes. Once we do that, we will get back to this element which has, apart from these 4 guys here, 4 nodes there, I will have 4 more at these places. Is that clear? So in order to develop this isoparametric or this element from an isoparametric fashion, okay, I have to now generate what is called as a natural coordinate system for a triangle. I will leave it with a small indication and then we will continue it in the next class because it is a very lovely idea. What is that we did in the last instant? I had say a point here, a point say P, we expressed it in terms of psi eta x y and so on. Okay, in other words we mapped or got psi eta in a fashion, okay, such that we can get psi and eta by joining. How did we get it? By joining midpoints on either side, we got psi and eta, mapped it. Here we are going to have another approach. Say for example if this is the point P, then I can join this P with the coordinates say 1, 2 and 3, 1, 2 and 3, and call this area here as A1, okay, and this area as A2 and this area as A3, and use A1 by A, A2 by A and A3 by A as a natural coordinate system. We will see that, or we will expand this in the next class. How we are going to do it, we will see it in the next class.